Hi, welcome to Software Design and Development, Implementation, Lesson 6, Techniques Used in Developing Well-Written Code. Here's the dot points that are covered. Pause if you'd like to read them. And as I say the last couple of lessons, please remember to take notes. Again, there's a lot of content here that you'll need to know, and you need to be taking notes so that you can process it properly. So these are the relevant good programming techniques that you need to employ when you develop a program. You need to have a clear and uncluttered mainline, one logical task per subroutine. You need to use stubs. You need to use appropriate control structures and data structures. You need to write for subsequent maintenance. You need to have version control, regular backups, and recognition of relevant social and ethical issues. A mainline is the main program. It's the section of code that decides what runs where. By having a clear and uncluttered mainline, you're able to see very easily what needs to run when, where the program goes to, and so therefore when you're tracking problems, you're able to find exactly where those problems are instead of having to read all the code and working out where they are. When you're writing code, you need to make sure that each subroutine only contains one logical task. This is not one operation. Example, print some variable. Okay, it's a collection of operations that work together to do one task. For instance, opening a file. There's a few lines that are relevant for that. You put them all in a subroutine and call it open file. Writing files, closing files, etc. Okay, you might have a game module that controls all the actions of your game. This would also contain other related subroutines. You might have a high scores module or a sorting array module or something along those lines. Each module should only do one specific job. Why is this good? Each subroutine does one logical task, making it very easy to find the problem if there is one. Okay, you just go straight to that subroutine and do it. If you don't do this properly, what will happen is you need to read every single line of code to find the problem, which isn't so hard when you guys are writing 200-line programs, but when you're writing tens of thousands of lines for a very large program, then you'll appreciate the awesomeness of one logical task per subroutine. It makes things really organized and nice to read. What's a stub? A stub is basically a subprogram that stands in the place of a subprogram you haven't written yet. And think of it like a placeholder. When you call the stub, it will do a couple of things. It might just output that the stub is running, so you can check that subprograms are called correctly. It might take a set of parameters and directly output a set of outputs. No processing involved. So that other parts of the program can call the stub, check to see that it passes parameters properly, and check to see that it will output the right parameters properly. So you can you can test the running of other subprograms and the main program as a whole without having this particular program written. And the advantage of this is that you can write things you can write programs that rely on a specific subprogram without having it written yet. And then when you eventually get it written, you should only need to do minimal testing because all the interactions have already been tested. Okay, so control structures are sequence, selection, and repetition. And these govern the flow of logic in a program and allow you to complete a variety of tasks. Data structures are things such as arrays of records, and files. They're extremely important when managing data, and creating them properly enables you to ensure the integrity of data and prevent errors down the track. Using the right control structures enables the program to work. If you need a loop and you use an if instead, obviously you get the wrong result. You can also increase efficiency. For example, if you have a massive nested if statement, you might have 6 different ifs. You can sometimes achieve the same job with a caseware, which would make it very easy to read and also make the processing more efficient. In terms of data structures, by thinking about what the data needs to do and developing data structures to reflect that, you're able to reduce the errors in development time. So one example would be making a street number a string instead of an integer. You prevent accidentally doing maths on it. Okay, and again, by developing an array structure correctly, you're able to count for the data you need, reducing time in redeveloping those data structures. Writing for subsequent maintenance. When you're writing code, you need to write with the idea that at some point your code will need to be changed. It's not because you write rubbish code, it's because at some point your code no longer does what it needs to do for the current purpose. Things that can help with this are large use of comments and frequent use of comments, meaningful variable names, and making the layout of your code easy to read. Okay, the reason that we do this is that you must change someone else's code and someone will have to change yours. So by making your next programmer's job easier, hopefully you'll make your job easier somewhere down the line as well. Version control. You need to save multiple versions of your code. Every time a major change is made, you should have a different version. You need to record each version with a version number, you need to note what is changed in the module, and you need to keep a record somewhere, a document, a database, something like that, that records all the different versions of all the different modules you've developed with all the details in them. And it's important to do this to track changes and to fix problems. Okay? Very basically, if you make a change and break something, you can go back to the old version. With having the old version, you can also see what the differences are and maybe get an idea as to what you changed and what broke something. And you're also able to see big picture, the development of the code over time, to see the vision of the project, where it's changed and so on. Backing up. When you back up, you need to do a variety of things. You need to make a separate copy kept locally for easy access. You need to make a separate copy kept externally for security from theft and fire, and you put one in the cloud in case of massive catastrophe. Making regular backups enables you to feel secure about your data and enables you to do something if something happens to your data. And there's a variety of reasons why that could happen. Data corruption, broken hard drives, theft, fire, act of God. The problem with issues with data, it always happens at the worst time. When I was in university, I actually lost my data twice just before exam periods. That was quite harrowing for me. And at that time, I didn't keep backups. They're super important for the productivity of the team and for the integrity of the project. Social and ethical issues are important things to be aware of. They include things like copyright, inclusivity, ergonomics. There's obviously a whole heap more. When you're aware of these issues, you're able to avoid any issues by not being aware of them. So obviously, copyright, you avoid legal issues by making sure you have the right to use certain things in your project. Okay? With things like inclusivity and ergonomics, you'll also make your software easily used, meaning happier customers and hopefully more customers.